All right, so for 2.3, we're going to look at angle properties of triangles specifically now, and we're going to go through a few properties of those. A few things to remember about triangles, even though I'm sure you've taken this before. Remember, all angles, they add up to 180 degrees. That's regardless. Also remember things like you have an isosceles triangle, which is where two sides are the same. The angles at the base of that triangle are going to be equal as well. And if you have an equilateral triangle like that, that means all your angles are going to be 60 degrees as well. Now there's a few new properties that we'll go over today as well, but for the most part, these are the things you're going to have to remember today, okay? Now, with angles or properties of triangles and everything like that, if you're given angles and you're trying to solve for other angles, I don't so much need a statement reason for this sort of stuff. All you really need to do is just show me some math, okay? And once I see the math, I can figure it out from there. All right, so don't feel bogged down having to do statement reason tables for all this stuff. If you feel like you can just show me mathematically, then do that. And it's easier with this stuff here because we're determining the measurements of angles. We're not proving things are parallel or anything like that. All right, so let's just quick one here, just to show you what I mean. So this is the first example, what we're going to be doing today. So we want to find these two measurements. I can already tell that they are going to be equal because they're vertically opposite. So I'm not too worried about, having to solve for one or both when I can just solve for one. And because we're dealing with triangles today, I'm going to deal mostly with this triangle here to solve for everything, all right? So first thing I notice is, well, if I look here, this is 140 degrees. So this part here, because this is a straight line here, has to add up to 180, so this has to be 40 degrees. Okay? Now I also see now, okay, I got two angles out of a triangle. That means I can solve for the other one. So that means angle 1 is going to be 70 degrees as well. Okay, and that's also going to be my angle 2. All right, so that's how you would solve these guys. Just show me some quick math, and that's fine. All right, now what's neat about this is if you notice, angle 1, these two interior angles, they just so happen to be equal, right? That part's wasn't intended, but we know that they're both equal, but they both add up to this guy here of 140 degrees, right? 70 plus 70 is 140. And that ties in with this statement here. That says the measurement of an exterior angle, so the angle outside a triangle, is equal to the sum of the measures of the two non-adjacent interior angles. All right, so that's quite a bit. The two non-adjacent, so by non-adjacent I mean the ones that aren't touching interior angles, the inside ones. So what that means if we break this down is if we look at angle D, that is an exterior angle off of angle C. So I could say that angle D equals the sum, so I'm going to add two things together, the measures of the two non-adjacent interior angles. So the two angles not touching angle D at all would be A and B. They're my interior angles. So if I added up angle A plus angle B, that would equal angle D. And that works every time. That's just a rule about triangles, okay? So whenever you have an exterior angle of a triangle, the two adjacent or the two opposite interior angles are going to add up to that angle, okay, every time. So let's try a couple of examples here. This is going to be based off of what we learned today, properties of triangles, and what we know about parallel lines as well, because you can see with this example I have parallel lines there. All right, so let's start looking at this. So I want to solve for 1, 2, 3, and 4. Now you don't necessarily have to prove them all in this order. It kind of depends on what you want to do. because I know that this is a straight line here, okay, and this line cuts it at 90 degrees, I know that this side is also going to be 90 degrees. Okay, so because I have now two angles of this triangle here, I know that angle 2 is going to equal 180 minus 90 minus 25. So I could say angle 2 is going to be 65 degrees. So since I know angle 2 is 65, I know that this is 65 as well because they're vertically opposite. So now that I have two angles here, I can also now solve for angle 1. Angle 1 is just going to be 180 because I have everything here, this triangle is going to be 180 minus 60 minus 65. So angle 1 then, if I work that out, equals 55 degrees. Okay, I'm just going to erase some of this stuff here just to kind of clean up what I got going on. That's 65 back here. So now I need angles 3 and 4. Now I'm going to work with angle 4. All right. Now if I look, angle 4 is an exterior angle of this triangle here. Okay. So that means I can work this out. Or it means I could have if I knew another angle. Actually, you know what? I got ahead of myself there. I should have went angle 3. Oh, not that. Alright, let's do angle 3 first. Okay. If I look at angle 3, right. If I look here, I have a parallel line and a parallel line. So I need to remember my properties of parallel lines. If I look here, with this transversal here, angle 1 and angle 3 are going to be alternating interior angles. So I know that angle 1 and angle 3 plus 25, all of this guy here equals angle 1, or equals, yeah, angle 1. And since I know angle 1 is 55 degrees, I know that angle 3 plus 25 degrees also equals 55 degrees. So I'm going to bring the 25 over by subtracting it, and I can say that angle 3 equals 30 degrees. All right, there we go. Now that I have angle 3, I can solve for angle 4. Angle 4, I'm just going to erase some of my mess here now. Angle 4 is an exterior angle of this triangle here. So that means if I add up these two angles here, I'm going to get angle 4. So I know angle 4 equals 90 degrees plus 30 degrees. So angle 4 equals 120 degrees. All right. Next one. All right, so for this guy here, now this is on page 88 of the textbook, in case you wanted to follow along. Okay. So I want to solve for NMO, so that's this angle here. And I want to solve for MNO, which is this guy here. And I also want to solve for QMO, which is that guy there. Okay. So if I look here, Let's start with angle M and O. This one here. If I look, I have two parallel lines here, here. If I look here, there's my two alternating interior angles. So I know that all of this plus this will equal 67 degrees here. Okay, clean that up a little bit. They form my Z. So this guy and then all of this are going to be equal. So I know M and O plus 20 degrees equals 67. So I can tell you right now angle M and O equals 47 degrees. So there's my first one. Cool, I got one. Now let's look at NMO. So I know this is 47. So if I look here and I want angle NMO, this one in blue, I know that all three of these angles, because they form a nice little triangle, have to add up to 180. So I know that angle NMO will equal 180 degrees minus 39 minus 47 degrees, because they all add up to 180. So if I subtract the first two from 180, that's going to give me 94 degrees. Okay, so look at that. So there, I'm off to the races. Now if I look here, remember it's all about your Z, properties of triangles, and well, because we have parallel lines here as well, it's probably going to be a bit of that as well. So I know now, I'm going to erase some of this stuff. I'll put some of it back. I know that this is 47, and I know that this was 94, right? Now if I look, I have two parallel lines. There's my C, right? And remember your C value, everything adds up to 180. So what I could say here is 180 is going to equal this angle plus this angle plus this angle plus angle QMO. So I'll say that 180 degrees equals 94 plus 47 plus 20 plus QMO plus angle QMO. So if I want, I can add this all up and solve for QMO. So I'm quickly going to work this out. 180 degrees equals 161 plus angle QMO. Bring the 160 over because I'm solving for it. That's going to be 19 degrees. Okay, so there's my three angles. There. Hopefully I didn't go too fast. If I do, just hit pause and keep going, okay guys? So things to remember from today, all three angles inside a triangle add up to 180. And remember this angle here, your exterior angle, is equal to the sum of your opposite interior angles. Okay, so here's your assignment here on page 90. Do 3 to 15 odd. Also, make sure you remember your properties of parallel lines. So remember to look for your C's and your Z's. Okay?